Good morning. Our study titled Selenium Levels in Healthy Adult Indian Population was conducted in All India Institute of Medical Sciences, Jodhpur. Selenium is an essential natural element that is required in trace amounts for the normal human physiology. Dietary recommendations for selenium differs from country to country because of the uncertainty in selenium's optimal level. As per WHO, the recommended dietary allowance for selenium ranges from around 70 to 350 microgram per day depending on the age of the individual. Different countries have different RDA recommendations for selenium. In United Kingdom, it is 70 microgram per day, while in United States of America, it is 55 microgram per day. In India, ICMR recommends an RDA for selenium of about 40 microgram per day. Now, the primary natural sources of selenium include both soil and water, and many countries, including Australia, China, and USA, have reported increased selenium content in soils. In India, the selenium status of the population is not equal throughout the country because of the difference in selenium levels in the soils at different regions of the country. This is illustrated by the higher selenium levels in soils in northwestern states like Punjab and Haryana when compared to the other southern and eastern states. And this increase in selenium levels in soil is being attributed to the intensive irrigation practices that is used by the groundwater. Concurrently, higher levels of selenium have been demonstrated in plants from the Punjab region. The aim of our study was to determine the average level of selenium in the Indian population based on the geographic region and to assess whether the different methods for estimation of selenium have any effect on the pooled values from the different regions. We have done a systematic search in the PubMed database to identify relevant studies published up to November 30th of 2020. The literature search was done using the keywords blood selenium levels in India. These were the inclusion criteria and exclusion criteria that has been used in this study. Once the studies were selected, the data were independently extracted from the text, tables and the figures. Pooled analysis were performed using Stata software version 13. The mean selenium level was used as the summary statistic and a p-value of less than 0.05 was considered statistically significant. We have used in the study a random effect model to combine the results. Coming to the results, the literature search performed using the defined search criteria yielded 68 articles, out of which 42 were excluded and 26 were qualified for full text review. After an extensive full text review, 13 articles were selected for inclusion in the final meta-analysis. The table illustrates the 13 studies that have been selected in this meta-analysis with the year of publication, the location of the study, the methodology of the selenium estimation and the sample size of the studies. On pooled analysis of all the 13 studies for the selenium levels from control subjects from Indian population, we observed that the pooled average level of selenium in control subjects was found to be 101.5 microgram per liter. Then we performed a subgroup analysis based on different regions of the country. And in the region-wise pooled analysis, we observed the central region to have the highest level of selenium, average selenium levels, and the eastern region of the country having the lowest average selenium levels. Because the method of estimation of selenium can have a predominant role in the levels that has been estimated, we went on to perform a method-wise pooled analysis of selenium levels. The three methods that we have included in the study are the colorimetric method, the atomic absorption spectrometry, and ICP-MS. And on performing the pooled analysis, we observed the higher average levels by AAS methods and the lowest average levels by the colorimetric methods. Because of the variation that have been observed in the method-wise analysis, we went on to perform a combined subgroup analysis on different methods and different regions. So as a first step, we have segregated those studies which have been performed by AAS method, and then we did a subgroup analysis on regions. And in this we have observed that the region-wise pooled analysis of selenium levels, when it was estimated on AAS, the southern region had higher levels and the western region had the lowest levels. The eastern region did not have any study that have been conducted on AAS. Similarly, we have done a region-wise pooled analysis of studies that have been conducted using ICP-MS, and in this we have found that the northern region had a higher pooled average selenium levels than the southern region. When we compared the studies that have been done using colorimetry method, we observed the eastern region to have the lowest pooled average selenium levels. It was around 33.08 microgram per liter. To understand the collective effect of geographical region and the method of estimation on the selenium levels, we undertook a meta-regression with the selenium levels as the dependent variable and geographical region and the method of estimation as the independent variables. In our meta-regression, we found that both the geographical region and the method of estimation significantly affected the average blood selenium levels from various studies. Selenium's normal blood levels vary between different geographical population, and various countries have evaluated selenium levels in the healthy adult population. This has been illustrated in this table. In our study, we observed the pooled average level of selenium to be 101.53 microgram per liter, and this varied between the methods, with the AAS having the highest pooled average levels and the colorimetric method having the lowest pooled average levels. Our analysis also demonstrated a selenium deficient status in the population from the eastern parts of India. However, the difference in methods of estimation hampers the comparison of different studies from other regions. So in the present analysis, the difference in estimation methods resulted in varying selenium levels, which prevented the effective comparison between India's various geographical regions. Now this points towards an imminent need for harmonization between the different methods before embarking on any policy change by the regulatory authorities. To conclude, a region-specific variation was observed in our pooled analysis, with the eastern parts of India having a lower pooled average selenium level, which signifies an inherent vulnerability to selenium deficiency and its associated diseases in this region. Identifying the region-specific variation will help the policymakers to devise strategies to target the vulnerable populations with better outcomes. However, the method-specific variation in the pooled average selenium levels. This highlights the prerequisite need for harmonization between the different methods while estimating selenium levels on different platforms. These are my references. And thank you for your patient listening.